Why do you want a single-ended triode amp? Hello, welcome to Lancaster Hi-Fi. Hey, please subscribe, really help out the channel. Be cool in the comments, leave me a comment, give me a like. Now on with the video. Why do you want a single-ended triode tube amp? Or do you? Should you? Here's the short answer to the first question. Because SET amps are pleasant-sounding distortion machines. And not because SET amps, in their simplicity, deliver the purest sound, the nearest realization of the straight wire with gain ideal. And not because, unlike push-pull tube amps, SET amps are Class A and therefore lack the crossover distortion that plagues push-pull amps, which are Class AB. And not because they're free of the compression imposed by amps with global negative feedback. Any questions? Other than, are you trying to start a flame war? 'Cause let me get that one out of the way. Yo, if it grows my channel, bring it on. But no, the truth is, I've been pondering the questions I started with. Should I want an SET amp? Do I? If so, why? And I don't mean to knock pleasant-sounding distortion machines. Dude, tube crunch is the shit. So yeah, I kinda do want an SET amp. In the rest of the video, I'll flesh out the short answers I gave at the beginning. But I'm going to hit those in reverse order. In explaining the not becauses, I want to dispel some myths and misconceptions and explain why a lot of amps that aren't SET amps are really excellent and don't deserve the bad rap they get in some quarters. Is negative feedback bad? Does it compress or constrain the sound? Does it stifle musicality, those notes straining to be free? No, negative feedback does not add compression, where that term denotes the reduction of dynamic range. Depends on what you mean by constrain. So if you mean that negative feedback constrains the output to better resemble the input, then yes, negative feedback does constrain the sound. And unless you think the notes have to be distorted to sound musical, of course negative feedback doesn't stifle musicality. Every time I hear or see that negative feedback is bad, I do wonder whether the author understands negative feedback. And when I hear the shorthand term feedback, I wince. And I think of my laboratory electronics instructor in college, Tom Hayes. Every time a student tells me they want to give me some positive feedback, I go... It takes an artist like Jimi Hendrix to make positive feedback a good thing. Positive feedback is the third base coach that waves on every runner rather than stopping those who will go too far and get tagged out. Yes, more of that! Negative feedback, on the other hand, simply corrects an amplifier that's doing a bad job of reproducing the input. A negative feedback circuit takes some of the output and feeds it back to the negative end of the input. If the output without feedback would be distorted, then the negative feedback distorts the input to compensate for and cancel out the distortion added by the amplifier circuit, so that the output comes out clean. It's frigging genius! Can negative feedback be implemented badly? Do I need a real mic? Duh! Those people who diss negative feedback, are they talking about the bad implementations? No, those people prefer their distortion machines, or they just believe negative feedback is bad for reasons. Yes, I am saying that people who really prefer amps without negative feedback do actually prefer amps that add harmonic distortion, and specifically amps that add even harmonics. But you're going to have to wait until, or skip to the end for my explanation of why some people prefer distortion. But really, negative feedback is awesome. When I first built the BV6V6, I was super psyched by its bass response and how low it could go without distortion. Then I realized that the sensitivity of the amp was over 3 volts RMS, and I reduced the negative feedback so that an input of 1.5 volts RMS could drive it to full power. And then I got really bummed out when I saw how distorted the bass became. That still bums me out. Friggin' low gain 6v6s, man. Are push-pull amps plagued by crossover distortion? Of course not. If they were, they'd sound like crap. Am I saying crossover distortion isn't a thing? Of course not. I'm saying that an amp with crossover distortion is badly designed. Please let me explain. I'll start with the usual explanation. One tube is responsible for the top, positive half of the waveform, and the other tube does the bottom, negative half. But neither tube quite gets all the way to the part of the waveform near zero, so you get this jaggy bit at the crossover. And that's just life. No way around it. All our Class AB amps suffer from crossover distortion, and only serious audiophiles can hear it, and it drives them nuts. Really? Almost every amp has this great gaping hole in the output. Only those with golden ears can hear it, and to them it sounds awful. Well, that's crap. I mean, yeah, you could badly design an amplifier, but no real amp designer is that bad because avoiding crossover distortion is pretty simple. You ready for this? Bias the tubes so they meet in the middle. Sounds tricky. What if you don't get the bias exactly right? Yes, well, bias the tubes so they overlap a little in the middle. Hell, bias them so they overlap a lot. WTF, bias the tubes so they overlap almost all the time. That's right. Good amps with Class B output stages actually run in Class A most of the time. Crazy, huh? Yeah, I know. Thing is, crossover distortion sounds really bad. So yeah. Now, I did say it's a thing. Have I seen it? Yes, I have seen that particular horror show on a scope. The first time, I'll always remember it. In my laboratory electronics course in college, when we were learning about push-pull amplifier circuits, our truly demonic instructor had us make a circuit that was designed badly on purpose to illustrate the effect. And I've seen it happen with amplifiers that I've built. I've even shown it in a recent video. It was on the jukebox amp. The Beaver Valley amp does it too. When driven way into clipping. Yes, that's right. A properly designed push-pull tube amp only produces crossover distortion after it's already clipping. Now, crossover distortion like that could be a problem if you plan on overdriving your amp. And guitar players do that all the time. On purpose. So with a guitar amp, you want to bias the tubes so you can overdrive the amp without crossover distortion. Yeah, just like that. I know. Heads must be exploding all over the internet right now. Is simpler better? Sometimes it is. And the straight wire with gain is a nice ideal. But it doesn't exist. Nor can any single component do the job on its own, whether it's a transistor or a tube or an op-amp. Components are added when, and only when, there's a job they're needed for. Yes, designs differ in their complexity. Design choices generally have their costs and benefits on both sides. In a recent video, I compared two solid-state amps, the Dynaco SCA80 and the Nico TRM 750. I pointed out that the Dynaco doesn't have a speaker protection relay. I modded that amp. Why didn't I add a protection relay? Oh God, I wasn't trying to take that on. In that case, I favored simplicity for its own sake, not because that simplicity made the SCA80 a better amp. I did take out the tone control circuitry. According to what I read, that circuitry was badly designed, and the easiest solution was to remove it and thereby improve the amp. Couldn't I have put in good tone control circuitry? Yes, but I couldn't find a design, and I didn't feel competent to design it myself. So I decided to do without. Well, as long as I'm all gung-ho for simplicity, why not remove the balance, the filters, and the loudness? Because I wasn't after simplicity for its own sake, and those features weren't doing any harm. And simpler isn't always better, just sometimes. Recently, I read the description of the Zen Triode on the Deckware website. The description touted the simplicity of the circuit and even bragged about the small number of components. Pure Class A single-ended triode amplifier with only 2 tubes, 2 resistors, and 1 capacitor in the signal path. If you're new to this amplifier, what sets it apart is the extreme simplicity, underlined. With only 6 parts in the audio circuit, there isn't much to get in the way of the music. Well, if less is more, take those resistors out of the signal path. Or did you need those to make the amp stable? Geez. And you know that every tube adds distortion, right? Distortion machine? Really? Yes, really. I came across that phrase in a forum, DIY audio, I think, about tube buffers, which some people like to add to otherwise solid-state signal paths to introduce the tube sound. Someone described tube buffers as distortion machines. I mean, he was right. If you just need a buffer to lower the output impedance, op amps are way more effective. Now, I don't really know how good tube buffers are at adding pleasant-sounding distortion, but SET amps rule in that department. I think the best way for me to explain harmonic distortion, what sounds pleasant and what doesn't, is to demonstrate with strings. This is a bass guitar. I can make it sound different by plucking the strings at different points along their lengths, or by changing the relative volumes of the bridge and neck pickups. So, right now I've got them both on at about equal volume. If I pluck right in the middle, if I pluck all the way nearly at the end, now I'll pluck right about here, but here with just the bridge pickup. And now with just the neck pickup. Making the bridge pickup louder has an effect similar to plucking the strings near their ends. And turning up the neck pickup has an effect similar to plucking the strings midpoints. A G string has that G as its first harmonic. That G is the tone corresponding to the first mode of vibration, where the whole string is swinging back and forth. Geez, I need another demonstration. Let me find a piece of rope. There, I've tied the rope at one end, and I'm over here. So by moving the rope at this end, I can excite various vibrational modes. So here's the first mode, otherwise known as the first harmonic. And yes, I took both physics and music theory in college. I'm not doing a really great job. Let's see if I can get this right. Okay, that's pretty much the first. That's good. Okay, let me try the second. See how there's that dead spot right in the middle, sort of? All right, I can try for the third. I don't think I'm going to get it. Yeah. You can kind of see what I mean with the third. I'm certainly not going to try to go for the fourth. When I pluck a string, or hit it with a felt hammer, or draw a bow across it, I'm exciting more than just the first mode or harmonic. The different sounds I get by plucking at different points or striking it or bowing it or using different pickups are from the different blends of the string's different harmonics. I can even eliminate the sound of lower harmonics by damping the string's vibration at strategic locations. Of course, first, second, third, fourth, maybe fifth, nah. So maybe you noticed, or maybe you know, that the even harmonics are at octaves above the first. Octave intervals sound good. The other intervals, the odd harmonics, those are like fourths and shit. The rules of counterpoint forbid fourths because they are deemed dissonant. They don't sound so nice. Not like thirds, sixths, and even fifths, and eighths, or octaves.
Oh my God, is he ever gonna get to the point?
Okay, tubes introduce harmonic distortion. Harmonics! Some more than others. Come on, you know what I'm getting at. SET amps go big with even harmonics. Push-pull amps, on the other hand, completely eliminate the even harmonics. And negative feedback, whether in a single-ended or push-pull amp, cuts down on all distortion. Yes, some amps are more accurate, by which I mean actual accuracy, not whatever gear reviewers mean by that word. I mean, I don't know what they mean when they say accurate. Anyway, so yes, SET amps are favored because they are pleasant sounding distortion machines. Now come at me. Tell me I'm wrong. Ignorant, trolling, misguided. Just come with receipts. I hope you enjoyed the video. Hope maybe you even learned a little something. I had fun doing it. And again, I kind of want an SET amp. Not trying to diss SET amps, just trying to take some of the mystery out of why people are so gaga over them. Even harmonics, they sound good. That's it. I hope I'll talk to you again soon. Take care, everybody.